This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Welcome to Software Engineering Radio. I'm your host, Gregory Kapfhammer. Today's guest is Jonathan Schneider, a co-founder of Moderne and the creator of OpenRewrite. He's the author of 2 books published by O'Reilly, focusing on topics like SRE with Java microservices and automated code remediation. Jonathan, welcome to the show.
Thank you, Gregory. It's a pleasure to be here.
During this episode, we will be talking about OpenRewrite. We're going to start the conversation by exploring what OpenRewrite is and the problems that it solves. Jonathan, let's begin by discussing the following question. What is automated refactoring and what are its benefits?
Automated refactoring is writing software that rewrites other software, and its main benefits are to achieve some modernization in that software, to fix security vulnerabilities, and to ensure a consistent style or fix these inconsistencies in code bases.
And if I'm understanding correctly, OpenRewrite is an automated refactoring tool. Is that the right way to think about it?
It is. OpenRewrite you can think of as a combination of 2 things. It's a rich set of data about a code base, so not just the text, but more information that the compiler would know as well. And then programs called recipes that operate on that data to make changes to the code base at large.
Thanks for that response. We're going to talk about recipes later in the episode. What I wanted to do quickly is to learn a little bit more about how you know an automated refactoring is correct. So can you talk a little bit about that? What does a software engineer need to do in order to ensure that OpenRewrite worked the right way?
Sure. The correctness really stems from some of the characteristics of that data that we mentioned earlier. So we're all used to operating and working with the text of code. But the first thing a compiler will do with the text of code is to take it and turn it into what's called an abstract syntax tree. So it turns it into this tree structure. The word syntax in the middle of that is interesting because it's really just the structure of the code. So where is a variable declaration? Where is there a class declaration, a method declaration, etc.? It then takes that AST and goes to a second phase whereby it goes through that syntax tree and tries to solve for all these names that it found. When it sees a method, what was the type that method was defined on? When it sees a variable, what is the type of that variable? And so it'll put information about that. We call that type attribution on the tree. If I'm then doing a refactoring on the syntax of code, say I want to change a logger statement, logger.info, then just the word info isn't enough for me to be confident that method came from a particular logger type. It's when a recipe is able to use the type attribution information that the compiler knows that this info method comes from a particular type that we're able to make that change. So type attribution is one of the essential elements of correctness in a recipe. But there's actually a soft form of correctness as well, which is interesting, which is that if we're going to make a change in a code base and suggest it to a user or to an engineer on that project, it needs to look stylistically consistent in the context of that code base. Now, you may be running one recipe across multiple repositories that have divergent styles. One uses tabs and spaces because, of course, we're never going to agree on that, different import ordering formats, etc. So OpenRewrite is designed to discover the style of the project heuristically from its existing style and massage a change to look idiomatically consistent in context. And so it's really those 2 things together, the compilable correctness and also the fact that the change follows the stylistic idiom of the project around it.
Thank you for that response. That was really helpful. I think compilable correctness makes a lot of sense because obviously if I refactor my code and it no longer compiles, then I'm really in big trouble.
That's right. You haven't done much.
So we're going to talk quite a bit more about recipes and syntax trees and the types that you referred to a moment ago. Let me ask another perhaps obvious question, but many people might have done a little bit of automated refactoring where they simply use something like a regular expression. Why are things like regular expressions not suitable for automated refactoring?
We tried really hard when we started this project, OpenRewrite at Netflix, about 8 years ago, to make a change to an internal logging library. We had an internal library called Blitz4j, which we came to regret. We should have just used SLF4j. So we were trying to transition from one to the other. They were very similar in structure, but the string literal, the first argument of the logger statement, used a different parameterization syntax, and the exception occurred first rather than last. And so we were just trying to use regular expressions to find these statements and shuffle these parameters around. And it just got very, very difficult because, as you can imagine, the first string argument to a logging statement may actually be a concatenation of multiple strings over multiple lines. The exception could be a method call. It could be a new class. It got very difficult to accommodate all the variation that existed in the code.
That makes a lot of sense. So essentially, unless we use an automated refactoring tool that is able to speak the language of a tree, then we're really not going to be able to ensure that we have correctness in our automated refactoring.
That's right.
Thank you for that. What I want to do now is just briefly comment on the language that you chose to implement OpenRewrite. Can you comment on that briefly?
It is written in Java, or originally is written in Java, because it did come out of Netflix and that organization used Java predominantly on the back end. So most of the thousands of microservices were written in Java.
Okay. And I know that Java developers can use OpenRewrite. What are the various programming languages that OpenRewrite supports in terms of automated refactoring?
We started in the JVM for that reason, because that's where Netflix's code was predominantly, and started to move from there in two different directions. One, in the simpler direction. Also, let's take care of our infrastructure as code. So that could be JSON, YAML, Terraform, HCL, properties files, text files, these kinds of things. And so you can refactor with that as well. And then in a different direction, it started extending from Java into Groovy and into Kotlin. Those are supported really well right now. And from there, actually added a COBOL or ZOS parser. Now we're adding a C# parser in the next 30 days, roughly. And we already have open source implementations of JavaScript and Python, although I expect those to change somewhat before they're fully GA, based on how we view supporting other languages right now. There's one interesting thing that we discovered as we started to write the parsers for JavaScript, for Python, for C#, is that at the LST level, that lossless semantic tree, so that's that syntax plus all the type attribution information. I hadn't given a name to it earlier. At the tree level, JavaScript and Python and Java and Groovy and Kotlin are largely the same, in the sense that they have the same elements, a method declaration, a variable declaration. They look very different in syntax when you actually print them out to text, but structurally they're very similar. And so when we went to write the JavaScript parser, we actually made it extend J, the base Java LST. When we went to write C#, we made it extend J, the base Java LST, such that many of the building block recipes that we wrote, like change method name and change method to target to static, those kinds of things, actually work on both languages without having to rewrite them.
Wow, that's really interesting. I heard you mention several times the word parser. Can you comment briefly, what are the inputs and outputs of a parser, and how do these parsers fit into OpenRewrite?
Sure. A parser is what we use to take the text of code and turn it into that lossless semantic tree. And the inputs to that can be quite complicated depending on what the language is. It isn't just the source files or the set of source files, but we also have to understand the structure of the project. Like a Java project can be broken into multiple projects inside of any given repository, and those projects have multiple source sets. Those source sets can have different dependencies from one another. So a compiler really needs a set of source files and its set of binary dependencies in order to be able to compile it. And so when we implement parsers, we tend to do so by integrating or injecting this parsing into existing language idiomatic build tools like Maven or Gradle, so that we can derive what the source set structure of the project really is.
So at a high level, if I'm understanding you correctly, I think that the input to the parser is the Java program or the C# program. Is the output of the parser some type of tree-based intermediate representation?
It really is. That's the lossless semantic tree. That's what a compiler normally does on its steady march towards a binary or a compiled representation at the end. But unlike the intermediate representation that the compiler uses, this intermediate representation is designed just to stay there temporarily and then be printed back out to text. So the compiler's AST or its type attributed form will have already discarded the white space of the project because that doesn't matter anymore, the comments of the original project because that doesn't matter anymore. And so we have to build a slightly different intermediate representation, one that's purpose-built for refactoring rather than producing a binary output at the end.
That makes a lot of sense. So if I'm a developer who's using OpenRewrite, when do I use it? Do I use it on my developer laptop? Do I use it in CI? Can you comment a little bit about when I would actually pick up and use OpenRewrite?
I think the answer is yes to every workflow. I think that there's places where it's used on a local machine where you can introduce CI quality gates that ensure that certain patterns are respected inside of an organization. But I think you also need to be prepared to act on the code base at scale at any given moment. And for those kinds of events like a log4shell or zero-day security vulnerability, where you need to systematically go through your code base and discover and remediate a particular pattern, developers tend, I think, to associate code-based automation with CI/CD. So the first thing they'll reach for in their mind is CI/CD because we've built so much interesting automation in that process. But we have to remember that not every repository builds every day. In fact, there can be quite some time. There could be months of time that pass for a particular stable repository that isn't actively being worked on. So when there is that kind of zero-day event where we have to go and look through the entire code base, we can't really rely, or we shouldn't only rely on CI/CD as the machine of automation to promulgate that change.
Thanks for that response. I think what you have suggested means that when I'm doing linting, I might want to do that in CI. But if I'm doing a patch for a security vulnerability, maybe I might do that on my developer workstation. Is that the right way to think about it?
Or that you would want some mechanism to issue mass pull requests for those kind of zero-day security vulnerabilities. Even specific kinds of change. I'll give you an example that's not security vulnerability related. Whenever Gradle releases a new version, we will do a mass commit to all of our 100 repositories to update that to our Gradle builds to the latest. I don't want to run that, even with OpenRewrite, I don't want to run that recipe on a per repository basis by having to clone each repository to my local machine and doing that commit. But if it's a migration from Spring Boot 1 to 2 to 3, where there could be thousands of changes, my tendency is to want to pull a repository down and apply that recipe, which itself could make those thousands of changes, and to be able to touch it, to be able to run it, to see it compile in my IDE, to poke around the edges before I even make that PR commit.
Thank you. Those concrete examples were super helpful. Let's talk briefly about a couple of clear ways in which people have used OpenRewrite. So you've already mentioned a zero-day exploit. Can you be very specific? What are the ways in which we would use OpenRewrite to patch a security vulnerability?
Absolutely. So the most interesting security vulnerabilities to me are ones where you require a combination of dependency and source code changes. I think the state of the art for a long time in mass automation has been things like Dependabot or Renovate that just bump dependency versions, and actually only direct dependency versions, you'll notice. But that vulnerability could be lurking in a transitive dependency 6 levels down, and whose remediation requires not only a bump in that dependency, but also a change to the code to use it. So one good example of this, I think, and just one of many, but is this remote code execution vulnerability in SnakeYAML. These poor deserialization libraries are always subject to additional deserialization gadgets. And so indeed, SnakeYAML was found to have that remote code execution. And the author did the right thing by making a change to the constructor to require an argument that wasn't previously required, and then did a major version release. So went from 1.x to 2. That's very difficult to just take a PR from Dependabot that bumps to 2 and everything's going to be okay with the world. You really have to make code changes as well.
That's a great example. Thanks for sharing it. I can absolutely see why using OpenRewrite would be very helpful there. You're already hinting at another thing that I wanted to talk about. I'm assuming it's pretty common to have to do various types of migrations to like the new API of some type of library or framework. Can you develop that idea a little bit further? How does OpenRewrite help with API migrations?
Absolutely. So this is where an API migration version going from Spring Boot 2 to 3, normally we look at a set of release notes. And that set of release notes has a detailed list of all the individual changes that you have to make. It's not just bumping to new versions, but there's new idioms, new patterns, some of which are suggested, some of which are required. And so each of those steps we would implement as an OpenRewrite recipe. Recipes themselves can be composites or holders of other recipes. And so what you wind up seeing is increasing orders of abstraction in the recipe itself. For example, moving from Spring Boot 1 to 2 to 3 requires you to move from Java 8 to 17. Moving to just Java 17 from 8 requires you to first move to 11. So you'll see this nesting of these recipes where the first step in migrating to Spring Boot 3 is to move to Java 17, but you also have to move to 2.7 first, which means you have to move to 2.6 first, which means you have to move to 2.5, 2.4, which means you have to move from JUnit 4 to 5, which means you have to move from Mockito 1 to 3. So it's like it gets very deeply nested. That Spring Boot 3 recipe as it exists right now in open source has 1,887 steps to it. That's how much change there's been just in the last couple of years in that framework.
So all I have to say is, wow, that's incredible. And from what I understand you saying, it sounds like OpenRewrite, if I use that recipe, can do all of those steps automatically. Is that the right way to think about it?
That's right. And when we talk about a migration like Spring Boot, that is such a broad ecosystem that I think you'll find that there's some dark corner of it that hasn't been covered yet. And folks will either contribute additional recipes to that pile, or they'll just accept this got me 95% of the way there and I make additional edits and that's the end of it.
Sure, that makes a lot of sense.
I think there's another important thing about that we haven't mentioned, which is that OpenRewrite has that word open on the front of it. And it has that word open because it's Apache licensed. And so both the parsers that produce the LST and all the recipes are Apache licensed. The intention is that they're usable in any product or experience that might be developed. And it's really important, I think, that these recipes are Apache licensed because effectively we are asking framework authors to start taking responsibility for providing recipes when they make breaking changes. So my expectation of the Spring team is if you break it, you fix it. And that if you don't, there's a competing framework like Micronaut that does provide auto remediation where it's breaking changes, that should be a decision criteria for me as an application developer, that I want to be using frameworks that are going to help me move forward as they make changes.
Yeah, that makes a lot of sense. So essentially what you're saying is, as an engineer, we should pick which frameworks we depend on based on whether or not they're going to help us during the upgrade process.
Absolutely. Because right now, a lot of our time really is spent on this mechanical, tedious work that should be automated and that we could write recipes for, but really should also be provided at large by the third party and open source libraries upon which we depend.
I know a lot of our listeners are going to be interested in learning more about how long it takes to run OpenRewrite. And you don't have to be overly concrete in this, but can you give us a rough estimate? How long does it take to run OpenRewrite if they were, like, for example, using the Spring Boot recipe that you mentioned before?
So there's two parts in a run with the open source tooling. There's the production of the LST in the first place, which is parsing those text to code into memory. And then there's the execution of these recipe programs over that LST. In the open source tooling, that's the parsing step is proportional to a clean compilation on the project. You really are running the compiler after all behind the scenes. And there's no incremental compilation possible there, really. So it's a clean compilation. And so the recipe run itself is comparatively short. relative to parsing. So we'll get into a little bit later, I think, the distinction between OpenRewrite and Moderne. But as a kind of hint towards that, understand that most of the recipe running time is dominated by parsing.
Okay, that makes sense, and I can understand where you're going with that. If listeners want to learn more about legacy code or how to improve legacy code, they may want to check out Software Engineering Radio episode 602. What I want to do now is to just pick up on a few of the topics that you mentioned previously. So you've already talked about how OpenRewrite does a type of static analysis, and then it produces something that's called a lossless semantic tree. So let's pick up on a couple of those comments briefly. First of all, what is static analysis and how is it different than dynamic analysis?
Sure, yeah. The static analysis is really studying the code base or the tree of the code base for and discovering facts about it that are determinable from looking at the source code, and maybe also the information that the compiler infers in that type attribution information. Static analysis is well known to be something where you can have completeness or you can have soundness. So you get to choose. You don't get to have both complete and sound analysis in many cases.
And to be clear, the kind of analysis that OpenRewrite is doing does not require the execution of the program. Is that correct?
That's right.
Okay. Now, before you mentioned the idea of a lossless semantic tree, and we've just been calling that the tree in part of our conversation, but what I wanted to pick up on is your use of the word lossless. What does it mean if a semantic tree is lossless in nature?
I think what we meant and we're trying to hint at with lossless was that the tree could be printed back to the text of the original code without losing any of the original appearance of the code, and also that we didn't lose any information that the compiler knew about in that second intermediate representation that may be used by a recipe to make an accurate change.
So why is it important for OpenRewrite to use an LST? I know a moment ago you said accurate, and before that you said you want the code to reflect the style. Can you comment on those issues a little bit further?
I think especially the second one, the style, is something that came out of its origins at Netflix. I was working on engineering tools, and Netflix had this special culture at the time called freedom and responsibility, which meant that a central team couldn't impose any constraints on what product engineers did. That led to wildly divergent styles between repositories in the organization. Contrast that with what Google is famous for with its monorepo and its Google Java format and other sort of strictures that ensure a consistency to the code base. That's not present at Netflix. That was 20,000 repositories that look different from one another. Now, I find that a large part of the world looks more like Netflix freedom and responsibility than it does like Google, either intentionally or accidentally. It could just be that you have 25 years of code and you have a layer cake or archaeology of styles, or you've acquired code through acquisition, or there's all sorts of reasons. But even if you want to be highly controlled in style, we find that that's not actually really true in most places.
So how does OpenRewrite store and manipulate these special types of lossless semantic trees?
So that's actually, again, a hint towards the later discussion. In the open source OpenRewrite parsers actually put those trees in memory, and the recipe writes or operates on them in memory. So in effect, they are not stored. They're always calculated at the time that a recipe is running.
Okay, and there must be something inside of OpenRewrite that creates these trees. I anticipate that this is connected to something called the visitor design pattern. Can you comment on how these visitors, which you mentioned once previously, work inside of OpenRewrite?
Sure. Yeah, the thing that produces the tree from the text of the code is the parser. And even in implementing a parser, we're allowing the compiler to produce its tree, and then we're using the compiler's visitor to navigate to every component of that tree, and then doing a mapping, effectively just like a domain mapping from an internal type to an OpenRewrite type. As we go down that tree, the visitor pattern in general, I think of it, this is an imperfect analogy, so bear with me, but I think of the visitor pattern as almost like an event-driven system for navigating the tree. So I may be interested in finding logger info statements, So I would be given a tree at the top, and I may override the visit method invocation method on the visitor because I only want to intercept or see method invocations. I don't care about binary concatenations. I don't care about class declarations. And so it allows me to narrow the search scope to a particular kind of syntax. And so in that respect, it's kind of event-driven. But unlike an event-driven system where you're just getting like a message bus event for everything that's fired, those visit methods in a visitor are also responsible for the navigation of the tree. So they will take a method invocation, for example, and call visit on the method name. It'll call visit on each argument, which in turn could cause many visitor methods to be called as well. And so by overriding, when I'm writing a recipe and I overwrite a visitor, when I'm overriding a method, I'm taking control of that navigation. By calling super on that visit method, I'm allowing the navigation to continue down the tree further. By withholding a call to super, I'm preventing the remainder of the tree from being navigated. I control effectively when it's called. I could look at information first, or I could call super first. And so it really is kind of the combination of those two things, navigation plus almost like an event-driven system.
That was really helpful. Thanks for explaining the visitor design pattern. There's one other topic I wanted to briefly touch on. It's connected to the fact that OpenRewrite has this cursor that helps you during node visitation. Can you comment, what is this cursor and how do I use it as a programmer who's leveraging OpenRewrite?
Sure. The cursor itself is really just a stack of the elements of the tree that I've visited to the point where I've gotten to this current event, this current thing that I'm looking at. OpenRewrite supports the idea of cursor messaging, which means I can put little pieces of data on the cursor as I'm navigating down the tree, or I can put cursor messages on ancestors of me up the tree so that when control returns back up in the visitor to that element, there may be data that I've found lower level that I use to make some sort of change higher up. So it's really just kind of a message passing system inside of the visitor itself.
That makes sense. Now, in a moment, we're going to talk about OpenRewrite and how it compares to other tools that do static analysis. Before we begin that part of our conversation, if listeners want to learn more about static code analysis, they can listen to Software Engineering Radio episode 59, which we'll link to in the show notes. So let's talk about some of the other tools that our listeners may have heard of. I anticipate that one that they may have tried out or read about is called Java Parser. So briefly, Jonathan, what is Java Parser and how does it compare to OpenRewrite?
Absolutely. Java Parser also is a technology used to parse Java's source code and perform some sorts of analyses on it. When I first encountered Java Parser 10 or 11 years ago, I guess, when this work began, it had some limited analyses or type attribution or the ability to solve for types on its tree. That implementation was outside of the compiler. It was in effect a simulation of what the compiler does at compilation time. And so I think OpenRewrite had a slightly different starting point where it was really started as just a data model of the tree and then used the compiler itself to compile and type attribute the code and then do that mapping exercise. So it was designed to work by mapping from compiler internal representations rather than mirror what the compiler did inside.
Okay, I see. Now, one other thing I wanted to briefly comment on is something called tree sitter. I remember you saying before that OpenRewrite has a whole bunch of different parsers inside of it, like, for example, one for Java or one for Groovy. And when you were saying that, it made me think of tree sitter parsers. So how does OpenRewrite connect to, use, or is it similar to tree sitter?
Tree sitter is mostly used to build the syntax tree, not the syntax tree with type attribution. And so in a similar respect, we could have used a AntLR parser to create the structure or syntax of a Java source file. We could have used tree sitter to create the syntax or structure of a Java source file. We could use the compiler's internal first step to produce the structure or syntax of a file. There's many different ways we could create parser generators or use parser generators to create the syntax. but TreeSitter doesn't go the next step to do that type attribution information. So it tends to be used in places where the analyses can be done on the syntax alone.
Yeah, that's a great point. And in fact, that's where I've used TreeSitter the most as well. Essentially, it's living inside of my text editor, and it can do things like syntax highlighting, but it's not necessarily picking up on the rich type information. And that's what I think your parsers in OpenRewrite are able to pick up on and then to leverage through the LST.
That's right.
Okay. Hey, that was awesome. Now, in a moment, we're going to talk about the specifics of how we use OpenRewrite for automated refactoring. And that's where we're going to dive into recipes, and we're going to talk about how OpenRewrite connects to the Moderne system. But before we get started, are there any other implementation details about OpenRewrite that you wanted to highlight?
I think we've covered what exists today. I think as we look forward to the next couple months, we mentioned this extension into other languages. And one thing that's very important, I think, to OpenRewrite as a community, as it expands into other languages, is to provide native recipe authorship experiences in the language that you're working to refactor. So I don't want a C# developer to have to write a recipe in Java using a Java visitor or using a Java code to modify their C# code. And on that level, we've started and will open soon a technology called remoting, which allows us to take that data, that LST model, and move it across process boundaries such that we can actually have recipes written in multiple languages operating on a particular LST. I mentioned that C# was also extending the JLST. So in the act of moving, say, .NET to .NET Core, I may have to change some method names. That recipe we already wrote in Java. So the first step in that recipe may be modifying a C# LST in a Java process. And then the next step was written in C#. So the data will pass to that C# process and a recipe written in C# will do that modification. And so this is going to be, I think, the first time where there's a language level cooperation, like recipes written in Java can benefit C# developers and vice versa. And that's a world I'm really excited about.
Yeah, I can see why that would be exceptional to have. And you mentioned something else that I would imagine would be very beneficial, which is if I'm a C# developer, I want to write my recipes in C# as opposed to having to use Java. I think at this point we should talk a little bit more about these recipes because clearly they're central to OpenRewrite. It sounds like there's an ecosystem of recipes that developers can use. Can you talk a little bit more about that?
Sure. There's almost 2,500 of these now. I think so. It's quite broad, cover a variety of use cases around modernization, security vulnerability repair, code quality type things. What's most interesting to me about this ecosystem is who the participants really are. And we mentioned one earlier, which is framework authors. So if you're a framework author making a break and change, it's really in your interest to provide a recipe because you're able to move your user base forward more quickly, which means you can actually innovate faster than you did. You don't have to hold on to these old APIs quite as long. And we see security researchers writing recipes that do remediation. There was an engineer by the name of Jonathan Lightshoe that issued the second most commits of any person on GitHub in 2022 via the execution of security vulnerability recipes he was writing and running and doing mass PRs for. And so you just see different parties, I think, working towards this common goal of manipulating their code base.
A moment ago, you mentioned that you could have recipes that were connected to code quality issues. What types of code quality issues can you detect through a recipe? Can you give some examples?
Absolutely. So this could be, think of the typical SonarQube, white source checkmarks, HP Fortify, Veracode, those kinds of tools that look for code smells, like potential null pointer exceptions, when the equals is comparison to a string literal, it has the literal second rather than first, and missing braces. It could be a wide variety of things, just little logic bugs and comparison operators. So whenever there's an existing rule like that coming from a scanning tool, like a Sonar Cube or one of these kinds of things. And we find that issue is widespread in an organization. We'll basically start and write an OpenRewrite recipe that not only identifies that issue, but fixes it. And that in effect becomes a substitution for the scanner. You just go and fix that issue at scale. We were working with a Canadian bank at one point that just looked at Sonar Cube and just picked the top 5 high severity, security oriented Sonar Cube rules. And Sonar Cube provides a manual estimate of the time it will take developers to fix every occurrence across their code base. And Sonar Cube said it would take them 4.9 years of developer time to fix just these 5 issues, right? So that's 5 recipes, not 500. It's just 5 recipes. And an engineer there pretty boldly actually took those 5 and a few others and mass committed those fixes to the entire commercial bank. So the inside of that day, that commercial bank's code base went from an E score in Sonar Cube to an A score in Sonar Cube. It's really unlike anything that they had done previously.
Wow, I have to say that's both jaw-dropping and incredible. What a great use of the tool. I'm wondering now, maybe we could use this bank as an example. What did they actually have to do to test their recipes in order to establish a confidence in their correctness? Because clearly this was a sweeping change across their code base.
Yes. So recipes themselves, Rewrite has a full testing harness for testing recipes, a unit testing harness, where you effectively provide before and after samples of code and run in the unit test itself in string literals that get syntax highlighted in the IDE and everything. So you'll think about the kinds of variations and encode each one of those in a unit test. And like any software that we test, there's things that we think of in advance and there's things we don't think of in advance. And so we'll unit test all the scenarios that we imagine. We'll mass run it on a code base. We'll look for patterns we didn't imagine, which feed back into those unit tests as additional cases to cover. And over time, the quality of the recipe gets more and more bulletproof. I think that's why it's important to be able to run efficiently across a whole organization when you're writing a new recipe and before you start distributing it to all the product teams, to be able to kind of see the impact that it would have on the whole organization first.
I'm assuming it's possible for a recipe to crash. Why would a recipe crash? And then how do you debug those recipes?
Sure, it can crash for a variety of reasons. After all, a recipe is a program, which I keep going back to. It's not a query language, right? It's more like a data warehouse for code, more like an OLAP system. Think of like a Snowflake, that kind of thing, not like SQL, just a query language. So you could throw a null pointer exception inside of a recipe for sure. The framework itself will capture or will trap those exceptions that happen inside of a recipe and record on something we call a marker, which is just a piece of data hanging on a tree node. It'll record as a marker on the tree element the recipe crashed on, the stack trace of what actually failed. So that later on, you can go and do this analysis. You could run it across hundreds of millions of lines of code and then group all the failures by their similarity to one another.
That sounds interesting. What I wanted to do now is to turn our attention to a very practical way in which a developer would get started. From what I understand, OpenRewrite has Maven plugins and Gradle plugins. How do they use those plugins in order to run a recipe?
Absolutely. So they would be adding those plugins. You can see this, by the way, on docs.openrewrite.org. There's a quick start guide right there for Maven and Gradle. So you're adding the plugin. In the plugin configuration, you're setting some recipe that you want to run from the existing catalog of available recipes, which are documented there as well. And then you run a build tool command, Gradle rewrite run or Maven rewrite run. And that will do both that parsing that we talked about earlier, also run the recipe and produce either a patch file on the side, or it will, depending on the configuration, just make the change locally on disk.
Okay. One of the things I wanted to talk about now is the commercial offering that is connected to OpenRewrite. Can you talk a little bit about what that commercial offering is and how developers can use it?
Sure. So what we just described there with the build plugins is really a single repository experience. You're going in and you're making a modification to a build configuration and you're running a recipe. We mentioned earlier as well that time where there was dominated by the parsing itself. Where Moderne really comes in is taking that LST. So the core piece of IP, the dividing line for us between open source and commercial is really the ability to take that LST model and serialize it to disk in a compact form. And that allows us then to build multi-repository experiences. So one of the first steps we will work on inside of an organization is to set up mass ingest where we're cloning hundreds or thousands or tens of thousands of repositories and running the parsers to produce the LST, storing them as artifacts. And actually, we store those artifacts inside of an artifact repository. So just Artifactory, Nexus, this kind of thing. We store them in that artifact repository and then provide different experiences to pull whole business units of code in the form of those LSTs and run recipes, run impact analyses as well, searches and these sorts of things across those business units. So that can happen very quickly because the LST has been stored in memory.
So one of the key features of the commercial counterpart to OpenRewrite is the ability to persist the syntax trees. Did I understand that correctly?
That's right. And that leads to these different multi-repository experiences, mass PR issuance. We are able to select in our IDEs as product engineers a whole business unit that we work on. That might be hundreds or thousands of repositories. And then in the IDE where you normally would have like a find usages button, you could say find usages on my business unit. And you'll find all such occurrences in repositories that I'm not currently working on. So you kind of get a sense of the scope of a problem. Similarly, for intention actions in the IDE, whenever you see a hint that there's something to fix, you can choose to fix right there. You can choose to fix in the whole file. That's what the IDE normally does, or fix in that whole project. Or you could say fix on my entire business unit. And so it's that ability. We're really trying to build these experiences that grapple with the fact that we don't work on one repository. We work on many repositories. That's the world that we live in.
Sure, that makes a lot of sense. I think many developers will connect with the fact that their code doesn't live in a single repo in a single GitHub organization, and so they need a way to span repos and span organizations.
When you think about GitHub itself, it really is very much a single repository experience, even to this day. You look at one repo, issues are attached to one repo, PRs are attached to one repo, commits are attached to one repo. And so this is the first foray, really, I think, into multi-repository action, whether that be impact analysis or remediation.
You mentioned a while ago in our conversation that you originally started working on OpenRewrite when you were at Netflix, and now there's a whole company surrounding this ecosystem. So what I'd like to do towards the end of our discussion today is to talk about some of the lessons that you've learned. You clearly know a lot about developer productivity and developer tooling. Can you share with our listeners some lessons that you've learned from building OpenRewrite?
We've learned so many, I think, even though there's been a lot of static analysis tooling or things that worked with the code, they've been predominantly scanners. They've really been built to search and to surface issues. That's a lesson I learned actually early at Netflix before the company was ever formed. When I was working on engineering tools, trying to move people forward to that new logging library, trying to move people to the next Java version, I also started with scanners, right? I started with dashboards and workshops and what can I do to make you move forward? And I think it's because of the harsh reality of that freedom and responsibility culture where people would say they just wouldn't do it. And you would say, what could I do? I'm here on my knees begging you. What could I do to make you move forward? And they'd say, do it for me. Otherwise, I've got something else to do. I'm not going to do it. And that's where I think this requirement of auto remediation, I mean, I was compelled to. It's not like I had a special insight. I was compelled to do this kind of thing. When we set out to do auto remediation, there was very little prior art to work with, I think. We saw IDE-based refactorings on a narrow level, which are really interesting and have come a long way in the last 20 years. But there was not a lot of like wholesale framework migration type things to work on. So we're on version 8 of OpenRewrite now because I've messed up 7 major times, at different points in the last 3 or 4 years. So that's an acknowledgement of our own shortcomings or inability to see some of the core functionality early on. So as a company, we say one of our predominant cultural tenets are humility and fierce resolve. So we will not stop. We're going to go find the way this compiler works, and we're going to find some way of exercising it and getting the data out of it. That can be very difficult, but we are always willing to see where we went astray. And I think that's why we've seen 8 versions. It's because we're willing to admit that where we're wrong and course correct.
Thanks for that thoughtful and candid response. I really benefited from it. I wanted to talk now, perhaps in a more forward-thinking or future-oriented fashion. Many software engineers are starting to use AI techniques in order to help them to do programming or refactoring. Can you comment briefly, how does OpenRewrite fit into this new landscape of AI-enhanced programming?
So this is such an interesting question, and you're going to get some answers here you may not expect. But the first thing to say, which I think you would expect, is that we ourselves are avid users of Copilot inside of our company. So I see the primary use of AI in code as an authorship experience that's accelerating this trend that's existed for some time of an increase in the volume of code under management already. So that bank I was referring to a long time ago, the one that fixed these SonarQube issues, they have 500 million lines of code right now, something like that. And so we had done this exercise, I think, in the book that we wrote for O'Reilly on automated code remediation, to say, if I were to print that code out into books and just stack them end to end, they would extend from Miami, where I live. We tried to go up the East Coast. They go from Miami all the way to Montreal in Quebec. And it's staggering, the volume of code that we have under management. So if I'm going to make a change to that 500 million lines of code, I don't want a system that has a low probability of hallucination or a low probability of incorrectness or inconsistency. I need a machine that has, it's almost like a Lean Six process, like a manufacturing process, low degree of variability, high degree of predictability. I need to be able to go and do that, because if I was to use a probabilistic system to make those changes, then the change requires human review to scale with it. I have to look at every single occurrence to be sure that every single occurrence was right. Okay, so we use AI for code authorship. That's been true for a while. I did a study a little bit ago. I wrote just a particular piece of code, and I actually recorded myself doing it and went back and counted the number of characters I typed versus the IDE typed versus Copilot typed. And I found that I wrote, I think, 13% of the code, kind of depressing in a way. The IDE wrote 76% of the code, and Copilot wrote that other 11%. So the IDE doesn't get enough credit. It does quite a bit for us already. I think AI-based authorship tools are complementary to it, but they're still authorship experiences. Okay, so if we accept for a moment that they are still probabilistic, and that's just fundamentally what they are, and so maybe not the best thing for this like mass remediation, then where does it fit in to this refactoring story? We've really found 3 pillars here. And so pillar number 1 is where a recipe, which is, think of it as a computer, gets an AI. So right now we're talking a lot about agents. That's AI gets a computer. I'm talking to ChatGPT. It gets better at math. It gets better at math because it's using some agent behind the scenes. But I'm talking about the opposite here. So a recipe, which is a computer, gets an AI to do targeted changes in code. We've had one such example of this where we had a code base written in French, and that over time, the Java comments had become misencoded because of encoding switches in the IDE. And so we were using the recipe to identify particular comments that had this problem, and then using the AI to try to find what the original word was and substitute it in. But there was no chance for it to make a breaking change because the recipe was in control and only allowing it to make changes to specific Java comments. So computer gets an AI. That's number 1. Number 2, I think is interesting, is recommendations, or trying to understand where there's room for improvement. And so in this respect, imagine you could just sample pieces of your code, like a method declaration, and say, ask a generative AI like ChatGPT. You could go do this right now. Just say, where is there room for improvement? And it's going to start listing out some things. Some things are going to sound crazy. Some things are right. And so we've been taking those recommendations and then matching them to the recipe catalog, those 2,500 recipes that exist, pre-running them. And when they make change, then we have a signal that there is something to do on the code writ large. And then number 3 would be in code search. And I think this is an interesting case where if you were to say to me right now, like, I want to go find every place in my code where I execute an HTTP client call with a particular header, how would I do that? I would have to know every HTTP client technology I'm using and go search for usages of those APIs. You'd have to kind of exhaustively know the variation in technology that exists. Current research has really, around code search, has been focused on finding method declarations because method declarations have comments on them. So there's a lot of text to latch onto. There's a lot of human text to latch onto and match against the query. But in our code, where we're using APIs, we don't have a lot of text. And so there's where the LST can help, where we can be looking at a particular call site and we can look up the type attribution, look up the java.comment, and actually inline those comments into the block of code that we're trying to match on and see if that adds to the AI enough language that it can latch onto to do that match. So 3 big pillars of use cases there.
Thanks for identifying those 3 pillars. It sounds like there's really a lot of ways in which we could fruitfully combine various types of AI coding assistance and what is already available to us as software engineers in the OpenRewrite tool.
Absolutely. Yeah, better together as usual.
I think that's a good point. Now, as we draw our conversation to a conclusion, Jonathan, is there a call to action that you'd like to share with our listeners when it comes to OpenRewrite or automated refactoring?
It somewhat depends on who the listener is. So I'll say if you're a framework author, if you're an open source framework author especially, but even if you're a vendor providing an API to your users, think about providing recipes to your users to help move them forward with you. It's good for you. It's good for your end users. They'll love you. And if you don't, we're coming for you. We're going to find a way. If you're a developer using those libraries, I think go to that docs.openrewrite.org, look for recipes that make that change, and start thinking in this way that you can fix horizontally across your whole code base.
All right. This has really been an exciting opportunity for us to learn about automated refactoring. Jonathan, thanks for being on Software Engineering Radio.
Thank you. Thank you for having me.
This is Gregory Kapfhammer signing off for Software Engineering Radio. Goodbye, everyone.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.